Hello, grade 11s, and I think we know what we need to do. We need to make it maths. Okay, so today we're going to look at two examples, and they're going to get us into the area rule. So if we're given this triangle that I'm in the way of, right, up here, and so take a pause, draw down the diagram, and hit OK when you're ready to get back. Okay, so we're back, right? And we've got our triangle drawn down. And our area rule, I'm just going to kind of write it down for this one. Our area rule says that the area of our triangle, let's do it like this, the area equals, well, remember we used to go half base times height, but that's all very well if you know the height. But here we don't know the height and we don't really want to work it out. So all you have to do is go a half, take two sides, multiply them together, and the angle in between. So it doesn't matter which, I'm going to go for this one. 5 first, and multiplied by that 6,79, and multiplied by sine of the angle in between. So sine 120 degrees. Okay, and into your calculator that goes, and tell me what you get. Okay, well, you've got whatever you got. I'm going to load up my calculator here and go 1/2 times 5,6,79 times sine 120 and 14,700 whatever it is. Okay, I have AB sine C, which means 14,7. Let's just go to one decimal place. Units squared, of course. I don't know what the units are, but they're definitely square units. Okay, let's do the other one. So I'm going to do the next one together, and let's say we start, and our angle we're going to kind of look at as C. So we're going to look at the two sides next to it. So we're going to go a half of, doesn't matter the order, of course, 6.79 times 10,25. And we're going to multiply that by sine of, let's move out of the way here, sine of 25 degrees, because that's the angle in between. So you see that idea? It's those two sides and the angle in between. And into the calculator it goes, and what do you get? Okay, well, whatever you got, let's see what I get here. So we got a half. I find it easier just to write 0,5. 6.79 times 10,25 sine 25 was it, and we get 14,7, right, to one decimal place. And of course these are going to be slightly different because these have been rounded off, these sides and these angles. But 14,7 to one decimal place, and again, unit squared. Okay, so how confident do you feel of doing the last way? Obviously, you'd only have to do one, but how do you feel? How is your confidence in finding out the area? If I get rid of that and I move further out the way, doing it the third way. Okay, well, let's hit it, right? So we've got still a half, two things multiplied together, and the last one is this angle at B. So sine of 35 is going to be the last part now. And again, doesn't matter what order. I'm going to go 5 and then 10,25. I have no real reason why I've gone that way around. So 10,25. Into the calculator. What answer do you get? And did you just feel like cheating and writing 14,7 because it should be the same? Okay, I feel like cheating, but let's work it out. So we got again 0,5 times 5 times 10,25 times sine of, this time it was 35, and 14,7 to one decimal place. Right, so same answer as I said. Of course, we'll round it off somewhere along the way. So that's kind of our thing. So I've got a pause here for, in general, if you've got some sort of triangle, doesn't matter, except it should look vaguely like a triangle. So you got some sort of triangle like that, and you want to find its area. Now, I'm just, the reason for my pause is I don't want to go, sometimes we go half AB sine C, but just somehow think about it as it's always going to be a half times two things times sine of that other one. So whatever those are. So half of this side that's going to be this bit over here, times the some sort of other side. Let's put that in over there as a color, and that angle that's between, so this angle over here is this part over there. That kind of makes sense. That I really want to impress upon you this idea of it's a half this side times the sine of the angle in between. And if that happened to be A, B, and C, or D, E, and F, didn't really matter. You can see that we made sure that we had the angle, the included angle, and the two sides around it. So there's my kind of, in general, with colors rather than labeling things A, B, C, D, or any sort of letter. So pop that down. Chat when you're ready for our second and final example. Well, if you're not, I'm ready and we're going along. So what we're going to do is use this to find the angle. So in this case, we're given that the area of some sort of triangle, ABC, is 10,39 units squared. We're told that B is 8 and C is 3. So let's just, how about jot down a quick diagram. Click yes when you got your diagram. I'm going to draw a diagram. Your diagram may or may not look similar. It may or may not. I mean, we might draw it slightly differently. But pop yes when you're ready. Okay, so you've got yours. I'm just glancing down at my cheat sheet to see, maybe I'll draw mine like this, and like that. Why not? I don't know. I mean, I'm pretty terrible at drawing triangles, it seems. Maybe you just draw your triangle like that. That's also fine. You're like, you know what? I'm just going to rock A, B, and C. I'm going to draw mine like this, though, and say, well, if I've got A, B, and C, we're trying to find what the angle here is at A. That's what we want to try and find. And we're told that B equals 8. Remember, by convention, that side B is opposite the vertex B, so that is 8. And you could have rotated your triangle around, that's fine. And C equals 3, so I'm going to do this in yellow and go, well, that's 3. And we're told that the area of this whole thing, let's go purple here, our area is 10,39 units squared. Okay, so there's kind of how I'm going to capture it. As I said, if you drew your triangle like that, that's all good. So how are we going to use our newfound formula to find out what the angle A is? And I'm interested to see what and how you put that. Yeah, I think we've got our formula that says, well, we're looking at this side over here, remember, this side over here, and the angle that's in between them, that one there. And what our formula says is that the area, well, we got the area, is equal to a half, those two things times together, times sine of the angle in between. So sine of A, we don't know what A is, but we know what these two things here are. Again, order doesn't matter. But there, we've just used our formula and we've subbed in the bits that we know. So now the question is, and go for it, what's the value of A? Okay, so let's kind of rearrange our equation here. So if we take this equation and we divided it by a half, 3, 8, right, those would cancel and we'd just have sine A on this side. And what you do on one side, you do on the other. So let's divide that by 3, 8. Now, you don't have to show that so much as I'm going to take this here and go 10,39 and divide it by a half times 3 times 8, and I get 0,86. Oh, there we go. That's what I'm doing. I'm putting in the calculator, and I get this left-hand side. Let's go for blue. Why not? 0,86. I'm just going to put kind of a ... to show that I'm not rounding off yet, but I'm just holding that. Makes sense. You with me? Okay, so now what we want to do is we want to find out what A is. Remember, if we've got what sine of A is, we go for that shift sign idea. So therefore, if we go shift sign of that, so A is going to be shift sign of that thing there. I'm putting it like that. So if we scroll down, go back to where's our calculator here, and we go shift sine of what we had before, we get 59,977. I'm going to call that 60 degrees. Okay, so there's what our value of A is. Except, is it? Of course, there's another little piece of the puzzle here. That is, I drew my triangle like that. Now, why could I not have drawn my triangle and had this as 3 and this green length here I'm going to make as 8, right? Still according to what we've been told, 3 and 8. This is still A over here. This is still B, and this is C. And now our last side of the triangle looks like that. And our area still equals 10,39 units squared. Why could that not have been a possible version of the triangle? And I'm just going to say it is a possible version of the triangle. So now the question is, that's one option for A. Or, what's our other option for the value of A? I'll give you a hint maybe for this one. Think of your beloved cast diagram. Where else is, so these are all, the answer that I just want you to give me is, what's the other possible value of A? But in kind of thinking our way towards that, where else is sine positive? Because remember, sine was a positive value here. So which other quadrant could you look in? And therefore, key question, what's the other possible value of A? Well, if we drew this in the second quadrant, and we considered this to be our value, 60 degrees is what our reference angle is. So this could have been 120 degrees. So A could also have been 120 degrees. Now wait a second. Does this make sense? Does a half times 3 times 8 times sine A equal 10,39? Okay, so let's have a look. A half times 3 times 8 times sine 60 is what we got at first. 6 through 3, 10,39. Okay, but now what happens if we change that to 120? 6, same answer, right? So we kind of need to have our trig in the back of our mind. Of course, this is still trig, but it's not just blindly entering into a formula. We need to have this in mind because we should know that sine 60 is the same as sine of 120. Remember, sine of theta is just the same as sine of 180 minus theta. So 180 minus 60 gives us our 120. Okay, so that's that. You got some exercises to do. Exercise 1 is yours, and just remember to make it maths.